Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to write the molecular, complete ionic, and net ionic equations for the reaction of lithium carbonate with magnesium sulfate. So let's get into this. So here uh, I have lithium carbonate and magnesium sulfate as my reactants. You'll see here that they have the names written, not the formula. So we need to go from the names to the formula. So you need to know how to do that. So if you need help with naming, go to my videos on naming and going back and forth between the names and formulas of compounds. Okay, so here the name gives you the two ions. So you have the lithium and the carbonate ions together. So we need to know the formula. We need to know the symbol of the ion as well as the charge. So lithium, that would be Li. And so lithium has to have a positive charge of 1. We know it's a lithium plus 1 charge because it's in group 1. And so a couple ways you can know how to figure that out is first, there's a general rule of if you're in the first three groups 1A, 2A, and 3A of the representative metals or representative elements, the group number will be equal, the positive charge on the ion will be equal to its group number. So if you're in group 1A, then you're going to have a positive 1 charge. If you're in group 2A, you're going to have a positive 2 charge, and so on. So that only applies to groups 1A, 2A, and 3A. The other way you can think about it, which is the better way, I think, is to think about the valence electrons and how the elements want to be like a noble gas. So if you're in group 1A, you have 1 valence electron. So remember, the group number of the 1A groups are the A group number is equal to the number of valence electrons. So if you're in group 1, you have 1 valence electron. If you're in group 7, you have 7 valence electrons. So lithium is in group 1, so that means it has 1 valence electron. So to be like a noble gas, it needs to lose that 1 valence electron. So it'll lose that 1 valence electron, and then by losing that 1 valence electron, it now unbalances the electrons and the protons. So you have 1 more proton than you do electrons. So that's why you have a +1 charge. So lithium has a +1 charge. Carbonate is a polyatomic ion. You have to know the polyatomic ions. So make sure you memorize those. I have a video on how to memorize and shows you patterns of the polyatomic ions that might help you to learn them quicker. But carbonate is one of those. So carbonate is a CO3 with a 2 minus charge on it. So right away, so we know that this is a 2 minus, this is a +1 charge. So what we need to do now is figure out the formula, and the way you figure out the ionic compound formula is you balance a charge. So there should be neutral charge, 0 charge. So notice that I have a +1 and I have a -2. So I need 2 of the plus charges to balance out the -2. So I'm going to need 2 lithium ions. The other way you could do it is do the crisscross method. So I could take a 2 here, and I have a 1 here. So the 2 I put there as a subscript. The 1 I can put here as a subscript. We don't write the 1s, but this is the crisscross method. So lithium, Li2, because of the 2, and then carbonate. I only have 1 carbonate, so CO3. So if you only have 1 polyatomic ion in your formula, you do not need to have parentheses. So Li2CO3 is the formula. And we could do the same thing with magnesium. So magnesium is in group 2. So since it's in group 2, it's going to have a +2 charge, 2 plus. And again, it's in group 2, so therefore it has 2 valence electrons. So it's going to lose those 2 valence electrons. And by losing those 2 negative electrons, it now has a 2 positive charge because of the unbalancing of the electrons and the protons in the nucleus. So here we have magnesium 2 plus, and then sulfate again is a polyatomic ion. That is going to be SO4 2 minus. So we have our sulfate and our magnesium. Notice there's a 2 plus and a 2 minus, so they're equal in charge. So I only need one each. You could do the crisscross method, but there is a caveat. There is something you need to watch out for. So if I do a crisscross method, I put a 2 on this side and I put a 2 on this side, I might write Mg2 SO4 2, and I might leave it like that. That would be a mistake. This is balanced. There is no charge, but we want our formulas, excuse me, we want our formulas to be in the lowest whole number ratio possible. So 2 to 2 can be simplified to 1 to 1. So that would be Mg SO4 with no parentheses. So notice that I have parentheses because I had 2 there, but since I reduced it, I only have 1, so I don't need the parentheses anymore. So that is going to be our second reactant, MgSO4. So I'm going to go ahead and erase this so we can get some room here. Okay, so now I need to figure out the products, and then we'll figure out what the states of matter are. So when you're figuring out the products, right away, when you look at the reactants, you should notice, look, I have 2 ionic substances. So whenever you have 2 ionic substances, that's a dead giveaway that you have a double displacement reaction or double replacement reaction. And so the way you find the products or figure out what the possible products are is that you switch the ions. So the inside ions are going to go together to form one possible product. The outside ions are going to come together to form another possible product. So the carbonate ion and magnesium go together, and the lithium and sulfate ion, those are going to go together. And the way we form our product is the same way we formed our reactants. We balance the charge. So lithium has a +1, sulfate has a -2. So I'm going to need 2 lithiums to balance the charge. So it's going to be Li2SO4. And then the 2 inside ions go together. So magnesium has a 2 plus charge and carbonate has a -2 charge. So it's a 1-to-1 relationship. So I only need 1 each for that formula. So that's going to be plus magnesium, positive ion, always written first, and carbonate, CO3. Okay, so now we have our possible products. The next thing we want to do is figure out the states, and we want to balance the equation. So let's balance it first. So I have 2 lithiums here, I have 2 lithiums there, so that's balanced. I have 1 magnesium here, I have 1 magnesium there, so that's balanced. I have 1 carbonate ion, I have 1 carbonate ion, and I have 1 sulfate and 1 sulfate. So this is a balanced equation. I don't have to do anything. Excellent. Okay, so what about the states? This is where your solubility table or solubility rules will come in. Your teacher probably gave you one. You could find one on the internet pretty easily. Um, so when I look at for carbonates, if you look in your solubility rule, it says if you look up carbonates, it'll say all salts that contain carbonate are insoluble, right? But there are exceptions. The exceptions are going to be, or for this one, there are no exceptions except for your group 1 elements. So if you have a group 1 metal with your carbonate, if you have a group 1 metal carbonate, that's going to be soluble. Or if you have ammonium, NH4 plus. So what do we have here? We have lithium, that is a group 1 metal. So although generally carbonates are not soluble, in this case it's an exception. So this is soluble, so it will dissolve in water. It'll be aqueous. So AQ for aqueous. What about magnesium sulfate? So if we look up sulfates, same thing, same rule. So carbonates and sulfates have the same rule. They are generally insoluble, except for when you have a group 1 metal or a ammonium. So here you have a group 2 metal. Let me check this out. So you have a group 2 metal. Okay, so here, no, I was wrong. So it says that all sulfates are soluble, and then it gives some exceptions. So it says silver, lead 2, your mercury 1, barium, strontium, calcium. So those would be exceptions. So your sulfates are going to be soluble, except for those exceptions. We have magnesium, so that is not an exception. So this is going to be soluble. So that is aqueous. Lithium sulfate, again, sulfates are soluble unless it's one of those exceptions. Lithium is not an exception. So it is a group 1 metal. So that's going to be aqueous. And then we have carbonates. If we go back to our rule, it says that carbonates, let's double check. Yes, so it says that all carbonates are insoluble except for your group 1 metals. So here we have a group 2 metal, and it is not, it's not going to be soluble. So this is not an exception. So this is going to be solid. So we have magnesium carbonate as a solid. Okay, so now that we figured that out, now we have what is called our balanced molecular equation. So the reason this is a molecular equation is because we're writing our ionic substances as they are molecules, as if they're molecules, right? We're sticking them together. But in reality, they're not together in the aqueous state. Remember, if you're aqueous, you're dissolved. Ionic substances that are dissolved, the ions separate from each other. They're not together. So we write a complete ionic equation in order to show that to be the case. So unless you're in a solid, the ions are not together. So here we'll write our complete ionic equation. So the way you do this is you separate all the ions like so. So I'm going to have the lithium ion. You write the ion with the charge, and it's aqueous. So this is a plus 1 charge. So this is lithium plus aqueous. And I have 2 of them. So the 2 subscript becomes a 2 coefficient. If I write the subscript here, that's saying that the 2 lithium ions are like bonded together. They stay together. That's not the case. So you don't want to keep the subscript. So in some circumstances, you'll keep the subscript. Like if you have mercury 1 ion, the mercury 1 ion is Hg2 2 plus. So that stays together. But outside of that exception and maybe a couple of others, they separate. So we have 2 Li plus aqueous plus your carbonate. So we have 1 carbonate, CO3, 2 minus aqueous. So that's this part here. Now we're going to do the same thing for the magnesium sulfate. So plus 1 magnesium, Mg, 2 plus aqueous. And then we have 1 sulfate. So that's going to be 1 SO4, 2 minus aqueous. Okay. So we've got our 2 reactants written. And so what we've done is we've taken the aqueous reactants and separated the ions into their respective parts. So now we're going to do the same thing for the product. So lithium sulfate is aqueous. So we have 2 lithium again. So that's going to be 2 Li plus. And we have 1 sulfates. Oh, I forgot the aqueous. Don't forget your states, AQ for aqueous. Plus your sulfate. We have 1 sulfate, SO4, 2 minus aqueous. And finally, we have our magnesium carbonate. And so this is a solid. We're not going to separate that because they are actually bonded together into a solid. So we're just going to keep it as a solid. So MgCO3 solid. And you always do that with your solids, liquids, and gases. So if you get a product that's a solid, liquid, or gas, keep it together. You might have an aqueous organic substance or a molecule that's dissolved. You want to keep that together as well. It's only the aqueous ionic substances that are going to be separated. Okay. So now we have our complete ionic equation. So our complete ionic equation is there. And so everything is balanced. And so what you see here is before you mix them together, they're separated. You can think of these as two different beakers, right? So this is one beaker and this is another beaker. And so before you mix them together, there are separated solutions in 2 different beakers. And then when you put them together into the same beaker, so this would be the same beaker, a reaction occurs. You get a solid forming, and that's your precipitate. Okay. So now we need to figure out our net ionic equation. And the net ionic equation is where you pull out what are called the spectator ions. And the spectator ions are the ions that are not involved in the reaction. And so there's a couple ways you could do this. You can look at the products that are formed, and anything that's involved in a solid or liquid or gas is going to be part of the reaction. Okay. And anything that's not part of that solid is not part of the reaction. So here we have a solid. And so those ions are part of the reaction. So everything else we can get rid of. The other thing you could look at is to see what ions stay the same on both sides. So if you have ions here that are aqueous and you have ions here, the same ions that are aqueous, those are going to be your spectators. So here we have 2 lithium plus ions. Here we have 2 lithium plus ions. They're both aqueous. So those are gonna be spectators. So we can cross them out. And then for the carbonate is part of a solid. So aqueous here, but solid there. So that stays. It's a player. Magnesium is an aqueous here. Magnesium is a solid here. That changes. So that stays. Sulfate aqueous. That's the same on both sides. So that's going to be eliminated. So these are the spectator ions. So when we write our net ionic equation, we write everything and just remove the spectator ions, and that's what we have left is the net ionic equation. So we just write you have your magnesium, right? So we have CO3 2 minus. Aqueous is you have your carbonate ion. You have your magnesium, so plus Mg2 plus aqueous, and then you have your solid MgCO3 solid, and there you go. So this would be your net ionic equation. So I hope this is helpful. I hope you enjoyed this video. I hope you got a lot of help from it. If you got some help from it, please like the video, hit that like button. Please put a comment in the comment section. Let me know what you think. And please subscribe to my channel. Hit the notification bell so you can get notified of any other videos I put out. Thanks for joining me. Have a great day.